So let us start today's session. So here is the first question, and here what has been given is okay. So what we have to find the ratio of the two poles of the circuit, and GM1 and GM2 are given. These C1, C2, and all these component values are also given, and we have to find the ratio such that the phase margin is 75 degrees. Okay. So for that, uh, let me write. Let's say omega 2 by omega 1. Let omega 2 and omega 1 be the two poles. And we have seen it in the last week also. We have solved this. So the ratio of the poles is given by a naught square minus 1 by 1 plus a naught cos phi minus 1 plus a naught cos phi. Where a naught is the gain of the circuit, DC gain. And here a naught will be, since it is a cascaded two-stage amplifier, so a naught will be what? A naught is generally what? GM and Z out, right? So here it will be GM1, GM2, R1, R2. If let's say RDS is approximately infinity, then Z out uh, is simply R1 and R2. Okay. If RDS here is infinity, then if you see the impedance from here, Z out will be simply equal to R1 parallel with infinity, that is R1. Similarly here. So that's why we have GM1, GM2, Z R1, R2. Okay. Anyway, so let me write it. R1, R2. So, and phi is also given to be 75 degree. So GM1 is what? GM1 is 323. GM2 is 1028 microsemon. R1 is 71.2 kilo ohms. And R2 is 9.7 kilo ohms. So if we solve this, we will get A naught equal to 229.32. Now we know A naught, we know phi, we know everything. So we can get W2 by W1 equal to 810.98. Okay. So this is the answer. So I hope this part is clear, as we did not introduce anything new here. This formula we had already seen in the last assignment. If you remember, we have done this derivation in the last assignment.
Yes, sir.
So let us move ahead. Yeah. Okay. So now we have to find the output impedance of the circuit, right? So let us do that. So okay, let me erase this first. So this is just the circuit that was there previously. This circuit and this circuit are same. So so what do we need to do for Z out, right? For Z out, what we do is we apply a test voltage source V. We see the current through it I, then V by I gives us Z out. Fine. So what will be the components of I here? So one part will go through this C2, one part will go through this MOSFET, some part will go here and some part will go here, right? So let me name them. It will be I1, this is I2, this is I3, and I4. So if we see I equal to I1 plus I2 plus I3 plus I4. So first, we know what is I2. I2 is ID GM VGS plus GD VDS, and since RDS is infinite, GD is 0, so it's simply VGS. Now, what is VGS? VGS is voltage at this node minus this is grounded, right? So let me draw ground. Source is grounded, and gate voltage here is VG. So first, if here the voltage here is V, right? Here voltage is V. Then what will be the voltage VG here? That we need to find by a voltage divider circuit. So we will draw a voltage divider first. If voltage here is V, here is it is C12. Then there's a capacitor C1. Then draw simply R1. Okay. C plus R1. Okay. So there is no VG here. So like there no current will flow through this transistor. So current will, so if I apply V here, current will go here and here, right? So this is simply what I have drawn. So if this is voltage V, we have to find this VG here. Let me write, we have to find VG. Okay, so what is VG? So VG will be equal to R1 parallel 1 by SC1 divided by 1 by SC12 plus R1 parallel 1 by SC1. Right. What is R1 parallel 1 by SC1? R1 parallel 1 by SC1 equals to R1 by 1 plus SC1 R1. So I'll put this value here. So let's see what we get. We get R1 by 1 plus SC1 R1 divided by 1 by SC12 plus R1 by 1 plus SC1 R1. Right, so this is VG. Simplifying a little further, if I take the LCM here, so what I will let me write 1 plus S. Okay, let finally what you will get SR1 C12. We have V times, right? So V 1 plus SR1 C1 plus C12, and I2, we know I2 is what? It is VG or VGS is the same thing, right? So I2 is just GM times this quantity. So I'll just write this GM2 SR1 C12 V whole upon 1 plus SR1 C1 plus C12. So we know out I2. Now let us see what is I1. So I1 is what? V by R2 simply. And I3 is what? SCU2 V. Right. And what is I4 then? So I4, what is I4? I4 is the current flowing through this branch, right? I4. So it is V minus 0 by this impedance. So I4 is what? V minus 0 by 1 by SC12 plus R1 parallel 1 by SC1. So I4 is C12 1 plus SC1 R1 times V whole upon 1 plus SR1 C1 plus C12. So till this point, are these currents clear? How are we getting these currents? Is there
Okay,
any doubt? Okay. So next we will just find V by I. We will find the total current and then do V by I. Okay, so what is total current? I1 plus I2 plus I3 plus I4. So let me write them. Equals to I1 was this current, right? It is V by R2. I2 is this current that is going flowing through the MOSFET. So I'll write plus GM2 SC12 R1 times V whole upon 1 plus S R1 C1 plus C12. I3 is the current through the capacitor, output capacitor. This, so it is SC2 times V, and I4 is the current flowing through here and going to the ground through this or this. So this current I4 is this, right? So let me write it. I4 is SC12 1 plus SC1 R1 times V whole upon 1 plus SR1 C1 plus C12. Okay, so this is I. So let's do I by V. Then for I by V, what will I do? I will just take the LCM of whole, right? So what will be the LCM? Let me write is, let's say R2 times this quantity into R2 is LCM. 1 plus SR1 C1 plus C12. Now what will be the numerator? So it will be V times this. It will be this into R2. Here this into both these two terms. Here this into only R2. So let me write all these terms. First is 1 plus SR1 C1 plus C12. Then here it is R2 times, let me write it like this, GM2 SC12 R1 into R2. Then this is, let me write here, SC2 R2 1 plus SR1 C1 plus C12 plus last term SC12 times R2 1 plus SC1 R1. Okay. So so I'll just try to rearrange this in 1 plus S square terms. So I by V is what? 1 plus, let's say S times. What are all the S terms? S terms are this one and this term. And what is the other one term will be from here and this. And one S term will be from here and this. So S term is C1 R1 plus C12 R1 plus uh, GM2 C12 R1 R2 plus C2 R2 plus C12 R2. These are all the S terms plus S square terms now. Okay, yes. So S square terms, we will have two S square terms. So here this S and this S will multiply to give us one S square term, and here S and S square term will come here. It will be okay. Okay, so let me just write completely as a whole. R1, R2, C1 plus C2 plus C12, C2 plus C1, C12. So I've combined them both together, but yeah, these will be the S square terms. Here it will be C1 plus C1, C2, C1. So here it will give C1, C2, then C12 and C2, then C12 and C1. So here we are getting this, and R1 and R2 are common in both. So this is the term. Now the denominator remains same. R2 1 plus S R1 C1 plus R1 C1 2. Okay. So this is just mathematics. Then V Z out is simply the opposite of this. So Z out is, let me copy this. I'm not going to write it again. V by I. Okay. So this is finally Z out. And if you carefully see, it matches with, I think, option A. It matches with option A, right? Yeah. So this is how you find Z out. It is simple. We just applied KCL everywhere, and we did not do anything else. We just took KCL at this node. For Z out, we applied test voltage V. Current going through is I. Then V by I is Z out, and we just found all the components of I, and then found V by I. Is this clear?
Yes, sir. Clear.
Okay. So this question does not have any numerical values also, so you can directly check your answers also, which one is matching with this one or this one. You can directly get the answer. You do not even have to do anything for this question in your assignment. Okay, so next question. Fine. So here, what they are saying is the design is to be compensated for a phase of 75 degrees by adding star capacitor something something. What is the value of CC? Okay, so what they are saying is, so what we have is this now, right? We have here C12, let me call it C12 dash, and here it is C1. So what they are saying, they are adding extra capacitor CC. This C12 now becomes CC plus C12 dash. C12 dash, okay, C12 dash is the one that was given in the question. Now they have added extra CC to give this. So they have added this CC to get this phase margin of 75 degrees by some compensation technique. So we will see what compensation is later, but till now we just know that they have added us some CC here, and now I will replace it by, let's say, for simplicity I'll write it as C12 only. C12. Okay. So and we have to find the this CC for which phase margin is 75 degrees. Okay. So let us see how to do that. So for Z out, we have already calculated. If this we have this kind of situation, what is the Z out? Z out is this. We have already calculated in the previous question. So if we look at the denominator, it is 1 something 1 plus S times something plus S square times something. So there are, since it is a quadratic equation, there must be two poles, right? So let me write it. So it has two poles. Let's say 1 plus S times T1, 1 plus S T2. If I solve this, it will be 1 plus S T1 plus T2, S square T1 T2, right? And what they are saying is, uh, uh, assumption is the ratio of the two poles is large. So that means one of the poles is larger. Let's say W2 is much greater than W1. So what is W2? Simply 1 by T2 is much greater than 1 by T1. This will give me T1 is greater than T2, right? So if T1 is much greater than T2, then we can ignore T2 from here, right? So we will get this as 1 plus S T1 plus S square T1 T2. So now if we compare this equation with this denominator term, we can see what is T1. So T1 term will be this time whatever it is multiplied with this S, and T1 T2 will be multiplied term with S square. So let me write it. Okay. So T1 equal to R1 C12 plus R2 C2 plus R1 C1 plus R2 C12 plus GM2 R1 R2 C12. Okay. Next, let me call it equation 1. Then T2 is what? Not T2, T1, T2 is what? Uh, C1, C2 plus C1, C12 plus C2, C12 times R1, R2. This is T1, T2. So what we have to find? We have to find the ratio of the two poles, right? So ratio of the two pole, let's say W2 by W1. So what will be W2 by W1 will be T1 by T2, right? So to find T1 by T2, what he can do is equation 1 square by equation 2. It will give T1 square by T1 T2 equal to T1 by T2, right? So we will do this. So we can get this. Let me write it. R1 C12 plus R2 C2 plus R1 C1 plus R2 plus GM2 R1 R2 C12 whole square C1 C2 C1 C12 plus C2 C12 times R1 R2. Okay, and what is this ratio of the two poles? We already know, right? This ratio we calculated as in previous question, A naught square minus 1 by 1 plus A naught cos phi minus 1 plus A naught cos phi. So this value we already know from question 1. What is x? Right, this ratio we already know from question 1. So we will just equate it with this x. So now we have this. So let me just copy it. Okay. So what our aim is, our aim was to find this CC, right? So for CC we have clubbed it. So our aim is to find C12 such that we have this phase margin. We have this phase margin. So this phase margin is corresponding to the x value that we have. For this x, what is the value of C12 that we have to find? So from this equation, we will form a quadratic equation for C12. So if I take C12 terms, if I separate C12 terms in from numerator and denominator, let us see. So C12 times R1 plus R2 plus GM2 R1 R2. Okay, so this is one C12 term plus we have something else R1 C1 plus R2 C2, and we have its whole square in the numerator plus 2x divided by, if I take C12 terms here also, C12 C1 plus C2 R1 R2 plus C1 C2 R1 R2. Okay, so now we can form a quadratic equation for C12, right? So I'll multiply it here. and then form the quadratic equation. So it will be C12 square R1 plus R2 plus GM2 R1 R2 whole square plus, so this is whole square, right? So it is a square plus b square plus 2 times ab. So plus plus b square. What is b square? What is r1 c1 plus r2 c2 whole square plus 2 times r1 r2 plus gm2 r1 r2 and r1 c1 plus r2 c2. Okay, we got c12 of these. So c12, yeah, minus. So this will multiply with this and will come here as in minus terms. Minus C12 x times C1 plus C2 R1 plus, sorry, R1 R2 minus x times C1 C2 R1 R2 equals to 0. So, okay, fine. So, let me reshuffle it properly. See, C12 square equal to R1 plus R2 GM2 R1 R2 whole square plus C12 times 2 R1 R2 plus GM2 R1 R2 R1 C1 plus R2 C2 minus X C1 plus C2 R1 R2 minus X C1 C2 R1 R2 equals to 0. So it is now of the forms C12 square into something plus C12 into something minus some constant C. So it is a quadratic equation now, right? So equation for C12. So you will get two roots. So simply you can do equals to minus b plus minus under root b square minus 4ac upon 2a. So this is a, this whole thing is b, and this is c, right? So you will get two values of C12 from here. One will be negative, which you will ignore. So I solve this, and on solving, what I get is, see, on solving, C12 equals to 4186 femtofarad, right? And if we are taking something, right? Uh, C12 equals to C12 dash plus CC. So 4186 equal to C12 dash plus CC. So CC is 4186 minus C12 dash, and this C12 dash is given in question. So in question 1, this value was given. C12 was 20 femtofarad. 4186 minus 20 femtofarad, 4166 femtofarad. This is the final answer. So it is a bit lengthy, but I request you to try it once. So the quadratic equation I have also already written. You substitute the values given in your question and you can find the answer. Okay. Is this clear?
Yes, sir, you can proceed.
Okay. Okay. So in the next question is, so now what they are saying is we had this, right? C12, or let us say we know the C1, let's say we had CC. We place another R here. Then they are saying what should be this value of R. So if you have seen the first video of this week, uh, so what this path contributes to is a zero, right?
Compensation.
Yeah. So uh, when we solved it, to move that zero to infinity, this R should be equal to 1 by GM of this transistor, 1 by GM2. So if GM2 value is already given, so it is simply this. So uh, do you want me to solve how the zero comes out to be this, and how do we get 1 by GM2?
No, sir, it's next is okay, sir.
Okay.
R value should be 1 by 2. So GM value will be 1 by half. So it turns out to be infinite. 1 by GM minus 1 by R.
Yeah, yeah.
So
1
R
by
minus
GM.
1 by minus R.
1 by GM minus R. Yeah. You should get in denominator something like 1 by GM minus R, right? So if R is 1 by GM already, then you get in denominator is something as 0, and it will tend to infinity. Then if your 0 is at infinity, that means it has no role in the circuit, and that we essentially want to do by compensation. Okay, let me solve it for sake. If this is the circuit, fine. So, okay. So, fine. Let me see. If this is V in, I've simplified it. I've taken just this part of the circuit. And if, let us say there is some voltage V in here and there is some V out here. I want to find what is the zero coming in the circuit. So, so let me apply. So I will apply KCL at this node. So if I apply KCL at this node, so first this current, so V out SC2 plus this current GM2 times V in, let's say RDS equal to infinity. So we can ignore GD term. So GM2 times V in only, plus uh, this this component V out minus V in by R plus 1 by SC12 minus this component. So it is V out by R2 equals to 0. So if I separate all the V out terms, SC2 plus SC12 by 1 plus SC12R minus 1 by R2 to V in times SC12 divided by 1 plus SC12R minus GM2. So, okay. Now I want to do V out by V in to find the zero end poles, right? So if I do V out by V in, so what I will get in numerator. So if I do V out by V in, so this term will go here, but this thing will come in the numerator, right? And this numerator term will numerator give by denominator. If we have the transfer function, then the roots of the numerator gives us zeros. So I'll just write the numerator term. So what is numerator term? Uh, SC, sorry, S, something is wrong. Sorry, give me a minute. Yeah. So the numerator term is SC12 divided by 1 plus SC12R minus GM2, right? So if I take LCM, C12 minus GM2 1 plus SC12. This we have something in denominator also. I'm just ignoring it. This is numerator only. Okay. And that LCM, the common factor will also go into denominator. So I'm ignoring that also. So this is numerator only. So the roots of this will give me zeros, right? So let's take uh, SC12 common. So 1 minus GM2, that is R also. 1 minus GM2R minus GM2. If I take SC12 common, it will be 1 minus GM2. Okay, so let me, okay, write its a simplified version. SC12 minus GM2 minus GM2 SC12R. Sorry. Yeah, GM2R it is, I think. R is inside. So if I take SC12 common, so SC12 1 minus GM2 R minus GM2. Okay. So now what I can do is I can take GM2 common also. So GM2 it will be 1 minus GM2, let's take common 1 minus C12 1 by GM2 minus R. So what is this form? It is something like 1 minus S times T, right? So our 0 is what? 1 by T. So 0 is, this is T, right? It's done. So 0 is 1 by C12, 1 by GM2 minus R. So now if this R equal to 1 by GM2, our 0 is 1 by 0, that is at infinity. So if our R is at 1 by GM2, we can move our 0 to infinity. That essentially means that we do not have a 0, right? And we want that in our circuit. So that is why we take R as 1 by GM2 here. Is this clear?
Yes, sir, clear.
So why do we want to move? Why do we want to move 0 to infinity and everything? This sir has explained in the videos. So please look at that also once. It will be very helpful. Okay. So last question. Uh, fine. So last question is also very similar to the thing, the second or third question that we solved, where we had to find the value of CC for which phase margin is 75-degree. So it is same. They have just asked us to take some approximations this time. Do not solve it completely. So anyway, so what we were getting, their answer is getting 4166. So even without solving anything, you can see which answer is nearest to the 4166. It is D part, right? So you can directly mark it. But anyways, we will try to solve it using whatever they are saying here, using some approximation method. But we know directly that answer should be something this because it is closest to 4166 that we had found earlier. So approximate solution should be closer to this. Anyways, let us solve it. Okay. Use Miller theorem to locate the pole at the intermediate node. So at this node, we will apply Miller's theorem. So here, this what is Miller's theorem? This C12, that is the capacitance between input and output part. It will be resolved as 1 minus gain into C12, right? So let me write. So what is 1 minus A is 1 minus GM2 R2. So this gain is nothing but only the gain of this stage. So its transconductance is GM2 and impedance will be R2. So it is 1 minus GM2 R2. Right. So 1 minus A is simply 1 plus GM2 R2. So if I write this, let's say T1 equals to, or let me write 1 by omega 1 equals to T1 equals to R times C, right? So what is R1? So in this node, this will be this R and these two C. So R1 into these C is the will be the pole here RC. So R1 into C1 plus 1 minus A times C12 R1 C1 plus 1 plus GM2 R2 times C12. This is what T1. Okay. So we have done the first step. For the second, what they are saying is assume that the second pole is such that at high frequency C12 and C1 are effectively short circuits and compute the second pole using C2 and the resulting resistance. Okay, fine. So for the second, calculating the second pole here, what they are saying is, uh, okay, they are saying that this, okay, fine, let us solve. So we know like the capacitance here is C2, but what, so, and we know the pole is 1 by RC, or if I'm writing 1 by omega 2, it will be RC. So C, we know C is equal to C2, but what is R here? R we cannot directly say here now R2 because they are saying that these two are very short and they will have some effect. So for that, let us calculate what is the impedance here, right? So if we apply, let me like this. If we apply test voltage V here and find the current, so this current will go here and here, right? Yeah, here also. So if we see VG, what is VG? Okay. So this is what C12. This is V. This is VG. This is what C1. So VG is what uh, C1 by C1 plus C12 times V. And this will give me, if I write the current here, ID equals to GM times VGS. So it is GM into C1 by C1 plus C12 times V is I. Okay. So now the thing is that this, if we see the values, okay, let us see the values again. So GM2 is what? 1 by 1028 microsieverts, and if 112 is 900, some 900 ohms. And this, so let us say some resistance somewhere here is 1 by GM times some factor, but it is in ohms. But this R2 was, I think, 71 kilo ohms or some in some large kilo ohm value. So most of the current will flow through this branch only. So if we assume V by I here, we will get uh, V by I as C1 plus C12 by C1 1 by GM. So that is the R value that we have here. So therefore 1 by omega 2 equals to T2 equals to R times C something. So our R is C1 plus C12 by C1 into sorry, it will be C12, C12, sorry, C12 into 1 by Gm times, and C is C2. So I have directly written this voltage divider, but you can solve it, right? So what Vg will be equal to 1 by SC1 by 1 by SC1 plus 1 by SC12. So on solving, everything will cancel and you will get this. I have directly written, but you can solve and verify this. What is Vg through this voltage divider? Okay, so through the second approximation, our T2 or the other 1 by omega 2, the other pole where omega 2 is the our second pole, we are getting is this. Okay, so what do we have to do next is, again, we have to do what we did in the previous question. We have to find T1 by T2, then equate it with X, and then find C12 using a quadratic equation. So now T1 by T2, we write, where we already know T1 is R1 C1 plus 1 plus GM to R2 C12 upon this term below, C1 plus C12 divided by C12 times GM into C2. So this is T1 by T2. Okay, so again, and this is equal to X. And that X was what it was, A naught square minus 1 by A naught cos phi plus 1 minus 1 plus A naught cos phi. So we have written it 5 times already, so we know T1 by T2 equals to, okay. So let me just move it in the numerator, C12 times Gm. So if I solve this quadratic equation and we separate C12 square terms and C12, okay, let me remove this. C12 square, we will get um, 1 plus Gm2 R2 Gm, R1 Gm2, right, plus C12 times uh, R1 C1 Gm2, this term, Cm2 times this minus X times C2 plus, sorry, again minus X C1 C2 equals to 0. So now we have another quadratic equation, and on solving, we'll get some value of C12, and again Cc will be C12 minus the given C12 value is 20 femtofarad, and Cc will be come out to be 4189 femtofarad. So this is the last question. Is this clear? There's similar analysis as to previous question, just we have approximated some, we have made some approximations to find T1 and T2 this time.
Yes, sir. So one last question, sir. One doubt
Yeah.
in assignment one.
Which assignment? Sorry.
Assignment one, question 8.
Assignment 1.
Yes, assignment one, question 8, sir.
Uh, Let me find out what was assignment 1. Okay. Do I have it somewhere? Okay, I did not solve question 8 last time. Okay, I'll open the question. Yeah, what is the issue in this question?
Calculations, sir.
I have not written question on here. Let me see if I have it.
Shall I share the screen, sir?
You can share it if you have it, please. Are you able to share this?
Here is the question, sir.
Yeah. Okay, so what problem are you facing in this question?
Like here, when this diode equations, especially this power expressions,
Okay,
this IL term, IL, this is a problem.
let me see. 1 second. IL is I naught minus IS exponential minus 1. So I naught is the current from the current source, right? So and I is the current going through the load.
Yes, sir.
So minus the diode current is IL. If you see the
Okay, sir.
diagram above. So what is the problem in IL? Sorry, I didn't get it.
IL is okay, sir. What is the problem is here this last two steps, sir, especially exponential of E0 by Vt and 1 plus VL by Vt exponential VL by Vt. These two terms somewhat appear.
Okay, let me see where they are coming from. 1 second. So, I naught plus for maximum power dual is equal to 0. So is equal to 0 and this exponential this is this. Let me try to solve it. Uh, so can you stop sharing your screen? 1 minute.
Yes, sir.
I'll share mine. Okay. So sorry. This is our load, let's say. IL is this. This is let's say ID. I naught equals to ID plus IL. ID is what? Uh, IS exponential VL by VT minus 1. So, and we have power here. EL equals to, sorry, E, what is the, VL equals to VL times IL. So it is VL times I naught minus plus IS minus IS EXP VL by VT. Till here it is clear, right?
Yes, sir.
Okay. So next, what are they doing to find the maximum power? They are doing dPL by dVL equals to 0. Okay, let us see how they do that. So if we want to take the derivative of this term, first we will uh, take derivative of this and keep this constant. Then we will keep this constant and take derivative of second term. It is chain rule. So we'll give 0 equals to I naught plus IS minus IS exponential VL by VT plus VL times this derivative of I naught is 0, IS is 0. This will give some derivative. We'll give minus IS. Yeah. We'll give minus VL by VT IS EXP VL by VT. Is this step clear? The derivative?
Yes, sir. Yeah.
So derivative is also fine. Next, what are they doing? Okay, next they have just rearranged, I think, I got equal plus IS equal to 0. And then 1 by dV. So, sorry, it will be minus 1 by VT. So, okay, this is fine. Then I not uh, taking IS common or what? Okay, they're taking IS common then. So I naught by IS plus 1 equals to this minus terms on the left side. So EXP VL by VT. Okay, let me write it more clearly. Fine. I'll take 0 equals to IS common. I naught by IS plus 1 minus EXP VL by VT plus VL, sorry, minus only, minus VL by VT EXP VL by VT. Okay, this is also fine. Then IS will can multiply here and go 0, so I'll just remove it directly. So this is what we have now. And if we take it to this side, exponential term, so we can get this is equal to, this step is also fine. Okay, is this step clear?
So it will be plus, I think, exponential of VL minus VT plus VL by VT.
Okay, yeah, plus VL by VT, right? Okay. Next, what they have done, they have taken log. Okay. Okay. So this is given in, I think, in the first line. I naught by IS equals to EXP VO by VT minus 1. So I naught by S plus 1 equals to exponential VO by VT. So it is replaced here by that. XP VO by VT equals to EXP VL by VT plus VL by VT XP VL by VT. Now if I take log on, natural log on both the sides, so I will get VO by VT equals to VL by VT plus log of VL Let me update log. Let's say ln VL by VT plus exp, not exp, plus VL by VT simply. There is something wrong. 1 plus VL by VT. 1 plus, okay. We've taken it common. Speed VL by VT. Speed VL by VT. 1 plus VL by VT. So U by VT equals to VL by VT ln 1 plus VL by VT. Uh, this is the equation that you are saying, right?
Yes, sir. Yeah.
So, okay, this equation is fine. Then what is the problem next? What were you not understanding? Next, they have just solved this equation, right? Iteratively.
Yes, sir. I think that's a mistake item.
What?
There is a
Sorry.
mistake. I have done that mistake, sir. That's why
Oh,
it's a blah.
okay. So this equation is clear, right? We are getting this equation.
Yes,
This is fine, no?
that is okay, sir.
Okay. So you are facing some problem in the further calculation.
Yes, sir. Further calculation, exactly, sir.
Okay. Iteratively solving it and we obtain VR. Okay. So we cannot directly solve this equation. For that, we have to use some iterative method. And uh, it's
Similar to the
perfectly,
problem one.
yeah, similar to problem one only. But what was there in problem one?
In the eighth problem, VL by VT expression is okay, sir. But what I did mistake is for the I0 minus IS exponential of, they are giving 25.98. That's the value I am not getting, sir. VL by V0 is
If they're giving VL by V0 is what? VL by VT they're giving, no? After solving it.
yeah, VT, V0 is 25.98 VT. That value, there is a problem in that value, sir.
Sorry, can you repeat what VL by what? V
V0 time V0 is equal to 25.98 times VT. That is the problem, sir. That's what I'm getting wrong. That after solving iteratively, sir.
okay. V0 is 23.98 times VT.
25, 25.8.
Sorry, okay, 25. Okay. What value are you getting for VL by VT by solving this? Do you have a value for VL by VT?
That I'm getting exactly 22.81, sir. Exactly that value.
22.81.
Yeah.
And here you are getting this, or you are not getting this. What the problem
Not
is?
getting, sir. I'm not
Okay, you're
getting
not
that.
getting this. Okay.
Yeah.
So I naught minus IS EXP 22.81 minus 1. Okay. Let me try to calculate. What is I naught? I naught is 3.64 milli. Let me write it first. 3.64 milli minus IS is 4.9 into 21 minus 11 milli. XP 22.8 1 minus 1.
Three point two four five. We are getting 3.245 milli.
Yeah. 3.245 minutes. This is IL. Okay. That's I not by minus equals to the bottom minus 1 and I don't understand this line. If we express I naught as IS EXP 25 point something minus 1, then V naught equals to this. Okay. Anyway, so can you drop me an email uh, with your solution? Then I'll try to figure it out. Will this be fine? Who was asking? Sorry. Bhuvnesh.
Sir, I will, yes, I will say it.
Yeah.
The
Can
network has,
you? Okay. So can you please email me your solution so then I'll try to solve it because it has taken too much time and I'll have to go through the that concept again. I do not remember exactly what we were doing in assignment one.
okay, sir, I will mail you, sir.
Okay. Thank you. Anything else? Uh, Venkata, do you have any problem?
No, sir. No, sir.
Okay. So let us close this week's session and if you have any problem, please email me. Let me show the email again. This is the email ID. Sorry. om.maheshwari@itgn.ac.in. You can email me that query and I'll try to solve it and return back to you. Okay. Okay. So let us end today's
Thank you, sir.
session. Yeah. Let us end today's session and we will meet next week for our last session. Okay. Thank you, guys.